So in this problem, if you want to see the actual scoring rubric, you can just Google 2010 number 2 scoring guidelines, and you'll be able to see exactly how I'm going to grade it when I go through your paper. Again, it's just for completion, but I will give you what your score would have been out of 9, so you can at least know what you would have been looking at. So part A says use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time 6. So E represents the number of entries. Sorry, hold on a sec. Okay, sorry. Sorry, I forgot where I was. The data in the table approximate the rate in hundreds of entries per hour that entries are being deposited. So this right here is how many entries are being put into the box at each given time. So if we want to know the rate of change of entries, then we need to do E of 7 minus E of 5 over 7 minus 5. And so that gave us, let's see, E of 7 would be 21, E of 5 would be 13, and so that's 8 over 2, which is 4. Now remember, this number on top was in hundreds of entries per hour. So this is 400 entries per hour. Okay, so 4 was all you needed to have. On the scoring rubric, you would have gotten 1 point for having that answer. Part B wants us to use a trapezoidal sum to estimate this quantity right here and then explain what that actually is. So there are 2 ways to do a trapezoidal sum. We can do T4. The area of a trapezoid is 1/2 times the height of the trapezoid times B1 plus B2. And we have to do that over and over and over again. So that would be, in this case, 1/2. Now the height of the trapezoid is going to be found by finding the distance between these 2 numbers. So the height would be 2. And if you plot those points on a graph, I think it makes it a little bit easier to see what you're trying to do there. And then B1 and B2 are going to be these numbers here, 0 plus 4. So that's my first trapezoid. My kids are unloading the dishwasher, it's loud. The second trapezoid would have a width of 3. And my bases would be 4 and 13. My third trapezoid would have a width of 2, and my bases would be 13 and 21. And my fourth trapezoid would have a width of 1, and my bases would be 21 and 23. So if you compute all of that, so all of this adds up to 85.5. Now that is my trapezoidal sum, but we need to actually take all that and we need to use it to approximate this, 1/8 of the integral from 0 to 8 of E of t dt. So my trapezoidal sum, T4, actually approximates this. And so I need to do 1/8 of what I got for T4 to get that actual value. And there are 2 possibilities here. I could have 10.687 or 10.688. They would accept either of those answers. Okay? So you would get 1 point for getting this number right here, the trapezoidal sum. You would get a second point for coming up with this number. Your third point, how would you get that? We need to be able to explain what this actually means. So I'm hopeful that when you saw this, you thought, that looks like average value of a function. And so I am hopeful that what you thought was that this was the average value of E of t. And E of t measures the number of entries in the box. So remember, we would need to include some discussion of what the 0 to 8 meant. So the best explanation for this is between noon and 8. Sorry, my stylus is terrible. The average number of entries in the box was 10.688. And that's, of course, in hundreds, right? I misspelled 100. Hundreds of entries, okay? You could have also changed that to be whatever that would be, 1,068 entries. That would also be fine. But that's the number of hundreds of entries in the box between noon and 8 p.m. Okay, part C changes this problem to a rate in, rate out problem. So we're going to call E of t the rate that it's going in. And we're going to call this P of t that they've given us the rate out. And so the question is, how many entries will not have been processed by midnight if they start processing at 8? Okay? So you'll notice that P of t is only good from t equals 8 to t equals 12. So that makes our life a little easier. We don't have to think about what's what. So the question is, how many entries are put in the box by 8 p.m.? So if you look, we actually have that data point. At 8 p.m., there are 2,300 entries in the box. So that was our rate in. Our number in, okay? And so now we need to figure out the number out. And so P of t is given as a rate in hundreds of entries per hour. And so if we integrate entries per hour, we're going to end up with the number of entries. So this is how many we had at 8 o'clock, and we need to subtract out how many they got through from 8 until 12 under P of t. And if you do that, you're going to get 23 minus, this guy ends up being 16. And our answer would be 7. Remember, that's in hundreds. This year, the kids were super annoyed by this 100 entries. They thought that was super annoying. It's a stupid thing. But anyway, so if you're looking at this from the scoring rubric, you would have gotten 1 point for knowing that you needed to use the integral. So 1 point for this guy. That would include having correct numbers here. And then you would have gotten a 2nd point for coming up with the answer of 700. Okay, part D says, using P of t in part C, when were the entries being processed most quickly? Now this is kind of an interesting question because they're asking us to find this when we have access to the graph. So I pulled up the graph over here of P of t. Let's see if I can graph on that. Yeah, this is P of t right here. And essentially, what we are trying to do is maximize P of t. We're trying to maximize when P has the most entries being processed at a time, right? So our goal is going to be, can we maximize P of t? And how would we go about maximizing anything? Well, according to our information about absolute extrema, so if you go back to Unit 4, Section 2, you learned how to optimize. And in order to optimize, what we need to do is we know that the maximum of a function can take place either at an endpoint or a critical point. So a critical point is a place where the derivative of the function would equal 0. So on this graph, those would be the places where my tangent line would be horizontal. And so there are two possibilities for that. That could be at t equals 9.1835 or at 10.8164. But remember, it could also happen at an endpoint. So we also need to consider the endpoints, which are 0 and, oh, just kidding, not 0, 8. Sorry. Which are 8 and 12. So we need to figure out P of 8, P of 9.1835, P of 10.8164, and P of 12. And so we need to find each of those values and see which one is the most. So if we plug those numbers in, if you plug 8 in, you're going to get 0. If you plug 9.18 in, you're going to get 5.0886. 10.8 would give you 2.9113. And 12 would give you 8. So we're looking for the maximum value, and that would be the maximum value of 8. The question says, though, at what time were the entries being processed the most quickly? And so your answer would be at, at t equals t equals 12. So how did they award points for that? You got 1 point if you said that you were considering P prime of t equals 0. So you had to write that out somewhere or make it obvious that you were looking for where the derivative would equal 0. You got a second point if you tested all 4 of these candidates. I think you had to have all of them. I think it is possible that if you left this guy off, you still would have been okay. But I think you at least had to have 8, 9, and 12. Okay? And your third point would be for coming up with the answer 12. So there's your last 3 points.